Hello student, good morning. I am Dr. Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have introduced nucleophilic substitution reaction and I have given just a brief idea what is the nucleophilic substitution reaction. Also I discussed it is of two types, SN1 and SN2. In that also I have discussed what is SN1 and what is SN2. Now SN2 reaction, last class I have mechanism I have discussed. Now I am going in details of SN2 reaction. Then I will come for SN1. SN1 is a bimolecular nucleophilic displacement. This SN2 is a bimolecular nucleophilic reaction. Here displacement takes place. It is a displacement reaction also. SN2. Last class I discussed the mechanism. Then there you have seen that that was reaction between hydroxyl ion OH minus, that was the nucleophile, and methyl chloride Cl was there. Then OH approached to the carbon atom, and as soon as OH approaches to carbon atom, then it will make bond. That bond you can show by ... weak bond, and same time Cl will try to leave. As soon as OH will approach there, that moment only Cl will try to leave and their bond will be also weak. That we can show ... Then at intermediate state both will be present, OH and Cl. OH will be attached with in the beginning with a weak bond, and Cl strong bond will now become weak ... Both are ... we can represent by ... means weak. And after that, as soon as OH will approach fully, it will make bond, strong bond, and Cl will leave. This is actually this reaction. Okay, intermediate now that will convert into the stable product. It will form CH3OH and chloride ion will be relieved. This is actually mechanism for SN2. This reaction takes place only in one step because it is SN2 reaction. Then here reaction actually takes place in concentration of OH ion, means NOH. Suppose NOH you have taken, that provides OH ion, nucleophile. Then this reaction takes place. This depends, the rate of reaction depends on NOH also and methyl chloride also. Rate of reaction here depends on OH ion as well as methyl chloride, or general way alkyl chloride. That's why it is called SN2. Okay, second order. Then second order reaction means it depends upon concentration of two reactants. Here OH minus and other is methyl chloride. Now I will continue. The incoming nucleophile interacts with alkyl halide, causing the carbon halide bond to break while forming a new carbon OH bond. Carbon and OH bond it will form. These two processes takes place simultaneously. Correct? Making new bond, breaking old bond. Then these two process takes place simultaneously in a single step, and no intermediate is formed. Only you can imagine This is actually transition state. Okay, this will for just you can imagine that it transition state this happens. It will not stay for more. Okay, this intermediate only for understanding purpose you can understand that this might have taken place, but this is of only one step. This intermediate is not stable. These two process means making new bond and breaking old bond takes place simultaneously in a single step and no intermediate is formed. As the reaction progresses and the bond between the nucleophile and the carbon atom starts forming, the bond between carbon atom and leaving group weakens. As this happens, the configuration of carbon atom under attacks invert in much the same way as umbrella is turned inside out when caught in a strong wind. Just it will reverse. Here situation is like that. This happens, as this happens, the configuration of carbon atom under attack by OH inverts in such the this under attack of OH under attack by OH, this carbon atom under attack inverts in much the same way as the umbrella is turned inside out when caught in a strong wind, while the leaving group is pushed away. Okay, this process is called as inversion of configuration. Inversion of configuration, just like in a wind, sometimes umbrella will be inverted. It will go outside. Like that way, here that molecule will invert. Molecule will invert. Just like an umbrella is turned inside out when caught in a strong wind, while the leaving group is pushed away. This process is called as inversion of configuration. In the transition state, that intermediate state you can tell transition state. In that transition state, the carbon atom is simultaneously bonded to incoming nucleophile, and the outgoing these things living group like chloride ion, and such structures are unstable and cannot be isolated. That's why we are telling it is not intermediate, because it can't be isolated. This is because the carbon atom in the we can tell transition state. Okay, transition means you will get product through transition state. We can't tell as a intermediate. Only for understanding purpose we can tell, but it is not existing. It can't be isolated. Then why it is not isolated? This is because the carbon atom in the transition state is simultaneously bonded to 5 atoms, and therefore it is unstable. Because methyl chloride is there, then CH3, 3 hydrogen already is there, fourth one is OH, fifth one is Cl. Then this is not stable, hence quickly it will give final product which is stable. Okay, then why it is not it can't be separated? Then this is because the carbon atom in the transition state is simultaneously bonded to 5 atoms, and therefore is unstable. Since this reaction requires the approach of nucleophile to the carbon bearing the leaving group, Okay, since this reaction requires the approach of nucleophile to the carbon bearing the leaving group, the presence of bulky substituent, or near the carbon atom have a dramatic inverted effect. Here it is important. The presence of bulky substituents on or near the carbon atom have a dramatic inhibiting effect. There should be no bulky group at the carbon. Okay. Why? Because have a dramatic inhibiting effect. Okay. Of the simply alkyl halide, of the simple alkyl halides like methyl halide react most rapidly. Remember, question is asked. Of the simple alkyl halides, methyl halides react most rapidly in SN2 reaction because there are only 3 small hydrogen atoms. Now what about tertiary halides? Tertiary halides are the least reactive. Remember, it's a very, very important point. Tertiary halides are the least reactive because bulky groups hinder the approaching nucleophiles. This, if bulky groups are present like tertiary halides, then it will what will happen? It will you can say it will not allow, or it will create problem for the nucleophile approaching to carbon. Tertiary halides are the least reactive because bulky groups hinder the approaching nucleophiles. Thus, the order of reactivity, you can tell primary halide will be faster than secondary, and secondary will be faster than tertiary halide. Okay. Then order of reactivity, this question is asked, primary halide will be faster than secondary, and secondary will be faster than tertiary. Okay. Then this I have told you, mechanism will be same way. Now if suppose only HH is there on the methyl group, 3H is there and 1X is there, you can understand it. Mechanism again I am telling you. Suppose nucleus is coming, then if it is a methyl, then quickly NU will NU means nucleophile will approach to the carbon. Now suppose now one hydrogen gone and one methyl group came, then this is called actually primary because now carbon is attached with other methyl group. Then means this carbon is attached with other carbon, means methyl group. Then now this is called primary. Then this is called primary when one carbon is attached with other carbon like methyl group. Now like that way, suppose now another H is replaced by other methyl group. Now bulky group, it is becoming bulky. Only one hydrogen is remaining now. Then now nucleophile will come with a little problem, with little difficulty. Because both methyl group will hinder the this approaching of or it will hinder the approaching nucleophiles. Now this is actually this is called actually isopropyl, and this is the secondary halide. And now if you can say already now it's this rate will be very slow and product you will get very less product you will get. And now suppose all 3H is replaced by 3-methyl group. Now it become more bulky. Then now it is just like a door is closed. How will you enter the room? door is almost closed. Correct? Almost. Means now nucleophile will feel problem in coming to the carbon atom. In approaching the or coming to the carbon atom, now nucleophile will face a too much problem. That's why reaction will be slowest you can say, very slow, almost zero, very less. That's why primary halide is, rate of primary halide is more than secondary, and secondary halide is more than tertiary halide. Question is asked. Now I am coming to discuss SN1 reaction. SN1. 1 means now it is the first order. Because it now, despite 2 reactant will be there, but rate of reaction will depend only on one reactant. That's why it is first order. But this will take place in 2 steps. SN1 will take place in 2 steps. Remember, and SN2 will take in 1 step without formation of intermediate SN2. But here, see, intermediate will be formed. Now I am going to details, try to understand, because many reactions are asked. Many times this question is asked. SN1 related question always is asked. SN1 reactions are generally carried out in polar protic solvents like water, alcohol, acetic acid, because all can provide H ion. That's why it is called protic solvents. Examples are water, alcohol, acetic acid, etc. The reaction between tertiary butyl or tertiary bromide, you can take example. The reaction between tertiary butyl bromide and hydroxide ions yields tributyl alcohol and follows the first order kinetics. This you remember, this example you remember, direct this example is asked. Tertiary butyl alcohol, remember, the reaction between tertiary butyl bromide, okay, and hydroxide ion, then reaction is actually easy. This is the butyl bromide, simply bromide, just like methyl bromide, alkyl bromide, simple, molecule is simple, alkyl bromide, but it is a tertiary. 3 methyl group or 3 alkyl group may be attached with the carbon. Then tertiary butyl bromide, with this carbon bromine is attached. Then tertiary reaction between tertiary butyl bromide and hydroxide ion or NOH. Then that OH ion only have to consider. This will yield, this will form, it will form only alcohol. Simple reaction, that ethyl bromide and OH. Cl will, Br will go, OH will attach. Reaction is simple, but mechanism is important here. Then here tertiary butyl bromide and hydroxide ions, it will yield bromide ion, hydroxide ion yields tertiary butyl alcohol and follows the first order kinetics. The rate of reaction depends upon the concentration of only one reactant, which is tertiary butyl bromide. Okay, rate of reaction depends only on the tertiary butyl bromide. Means with carbon 3, as for example, with carbon 3 methyl group is attached and bromine is there. 3 methyl group and 1 bromine is there, bromine atom. Then this plus OH minus, then reaction is simple, that Br will go outside, OH will make bond. It will form CH3 whole 3 COH. OH bond is formed plus bromide ion. It went. This is actually called 2-methyl 2-methyl propane 2-ol. 2-methyl propane 2-ol. With this carbon, 3-methyl group is attached. You can tell tertiary butyl alcohol also. And also IUPAC name we want, you can tell 2-methyl, because 1-methyl is attached with second carbon. Correct? Then total is the 3 carbon in that second carbon has methyl group. Then 2-methyl propane 2-ol. Okay. Now mechanism you try to understand. This reaction occurs in 2 steps. In step 1, the polarized CVR, because bromine is electronegative and obviously it will polarize the carbon. Bromine will be negative, carbon will be positive. Delta positive, delta negative. Then this reaction occurs in 2 steps. In step 1, the polarized CBr bond undergoes slow cleavage. Slow cleavage means it will break slowly to produce a carbocation. It will produce carbocation, means carbon will have some charge, delta plus, and a bromide ion. Okay, it will cleave, bond will slow cleavage, means bond will break slowly and it will produce a carbocation and a bromide ion in 1 step. The carbocation thus formed, now second step you understand, the carbocation thus formed is then attacked by a nucleophile in step 2 to complete the substitution reaction. Very easy. First carbocation formed in first step. In second step, now a nucleophile will, because it's a negative charge, that will attack to the positive carbon, carbocation, and it will form the molecule. Okay, this is the simple mechanism. The carbocation thus formed is then attacked by nucleophile in step 1 to complete the substitution reaction. Okay, then here carbocation, you know that now carbon is there. From that carbon, 3-methyl group is attached, and on carbon plus charge is there. Plus charge is there, plus bromide ion. Then this plus charge is called carbocation. Carbon having positive charge, and other groups, other alkyl groups, here 3-methyl. Then this is called carbocation. Then this actually is the first step. Trimethyl, you can say this trimethyl, you can tell methane also, trimethyl bromide also you can tell, trimethyl bromide also you can tell, or you can tell tertiary butyl bromide. Also you can tell tertiary butyl bromide. Then that in first step produces carbocation, and now carbocation is going to be attacked by OH in second step, and it will form trimethyl alcohol, also called 2-methyl propane 2-ol, and also called tertiary butyl alcohol. This I have discussed. Okay, this is the simple mechanism. Step 1 is the slowest and reversible. Now extra things, you know, question is asked related to SN1 and SN2. All points are important. Then now other important point I am telling you. Step 1 is the slowest and reversible. Not only slowest, it can get back also, reversible. It involves the CBr bond breaking, for which the energy is obtained through solvation of halide ion with the proton of protic solvent. Here you have to understand. This slow step I am talking about, it involves CBr bond breaking. This bond will break. This step involves the CBr bond breaking, for which the energy is obtained. To break this bond, from where energy will come? Then this, for breaking the bond, energy is obtained through solvation of halide. Halide will go to water, then that time it will release energy. Due to the solvation of halide ion, that time it will release energy. That energy will be used here to break the bond, CBr bond. Then this slowest step involves the CBr bond breaking, for which the energy is obtained through solvation of halide ion with the proton of protic solvent. Since the rate of reaction depends upon the slowest step, the rate of reaction depends only on the concentration of alkyl halide and not on the concentration of hydroxide ion. This is very, very important. The rate of reaction depends only on the concentration of alkyl halide, not on the concentration of hydroxide ion. Why? Since the rate of reaction depends upon the slowest step, correct? Rate of reaction depends upon slowest step. For that reason, the rate of reaction depends only on the concentration of alkyl halide and not on the concentration of hydroxide ion. How fast it formed carbocation, that is important. Further, greater the stability of carbocation, greater will be the ease of formation from alkyl halide, and faster will be the rate of reaction. Okay. Again, I am telling you that the stability of carbocation, greater the stability of carbocation, greater will be its ease of formation, okay, from alkyl halide, and faster will be the rate of reaction. Understood? Greater the stability of carbocation, greater will be its ease of formation from alkyl halide, and faster will be the rate of reaction. In case of alkyl halide tertiary, why I am telling here, focusing here, because you have first carbocation have to form. It should form fast. Then when will be stable? When only one there is no bulk group, then it will carbocation will be formed easy. Stability of carbocation means there should not be more number of alkyl groups attached to this carbon. This is the actually point. Then this greater the stability of carbocation, greater will be its ease of formation from alkyl halide, because this more alkyl groups are not attached, bulky are not there. That's why if it is not bulky, it will be stable. And second important point here, faster will be, if it is not bulky carbocation, then rate will be faster. Okay. Faster will be the rate of reaction. Now, if suppose tertiary alkyl halide is there, in case of alkyl halides, tertiary alkyl halides undergo SN1 reaction very fast because of high stability of carbocations. Higher stability of carbocations. Okay. Then how they are becoming these things stable? Then here one more thing you have to understand. Methyl group, methyl, there should not be a bulky group, that is correct. But for the stability, because if any group which can donate this methyl group, here methyl group, suppose it is a tertiary, in this in case of alkyl halides, now just to understand, in case of alkyl halides, tertiary alkyl halide undergo SN1 reaction very fast. Why? Because of the highly stability of 3 carbocations. Okay, and here that anyhow carbocation should be stable. It is observed that tertiary alkyl halide undergo SN1 reaction very fast because of the high stability of 3 degree carbocation. Okay, then how it will get stability, that matters now, but it is not a very bulky group, so that OH group should not come. This also you remember. Then you can just understand order. I am telling you order of reaction. Tertiary alkyl halide will be the fastest. Tertiary halide will be the rate of reaction will be, you can say, very fast. After that secondary halide, and then primary halide, that is the CH3X, and that I have told you tertiary halide. This I am comparing you for SN1 and SN2. SN1 and SN2 both reaction I will compare. Okay. Then for SN2 reaction I am telling first tertiary. That tertiary will be least and then secondary will be more, and primary halide will be highest. Correct? This in SN2 rate of reaction, primary will be highest, fastest you can tell, and after that secondary, and least will be tertiary. But in case of SN1, this situation will be reversed. Means primary will be less than secondary will be less than tertiary, means tertiary will be very fast, because here this carbocation will be stable. That is the mean presence of methyl group, 3 methyl group, it will be strong. Carbocation will be strong. Okay, that's why it will be this carbocation will be fast, and because OH coming, rate of reaction does not depend on OH attack. Okay, main rate of reaction depends upon formation of carbocation in SN1 reaction, because this is the you can say SN1 first order reaction, and this OH is this coming in the second step. That is not very important. Okay, that's why now order has SN1 and SN2. In SN1 order is reverse, but in SN1 you have seen, SN2 you have seen that directly this different ethyl group will be attached on carbon, means in a halide, then it will create problem for the OH ion to come near the carbon in case of SN2. But here it requires carbocation. carbocation, then whatever if carbocation is stable, then that decides the rate of reaction. And if it is stable, then OH ion can come from the back side and it will bond the it will form the bond. Okay. Now further I am telling you, for the same region, allylic and benzylic halides, SN1 reaction I am telling you what I discussed, the same reasoning. For the same regions, allylic and benzylic halide show high reactivity towards the SN1 reaction. The carbocation thus forms get stabilized through resonance. Here in case of benzene ring, I am telling you that benzylic halide or allylic, okay, for the same regions, allylic or benzylic halides show high reactivity towards SN1 reaction. Why? The carbocation thus formed gets stabilized through resonance. Then suppose with benzene group CH3 was there, toluene. Suppose that from that toluene, suppose one hydrogen gone. Okay, then it will form CH2. Suppose CH2 is there with benzene group, CH2 1 plus is there, CH2 plus is attached. Then what will happen? Resonance will take place. C has a positive, this is positive carbocation. This is actually carbocation, correct? CH2 1 plus is there, and from that carbon benzene is attached. Then now it became benzylic halide. Then now resonance will take place, means from the benzene double bond, with the double bond only that carbon CH2 is attached, plus means carbocation. Then now this will take place, resonance will start. That double bond will now it will go with single bond, because that carbon and CH2 was having single bond, that will become double. And now after that alternate movement will start. Which was single, that will be double, and double will become single. Then this positive charge will revolve around the benzene. Okay, because now on that carbon positive charge was there, CH2. Now because double bond shifted to the that carbon and CH2, that became double, and because this double bond that one bond went with electron, then that carbon from where it is leaving, that will be plus, correct? And then again it will affect to the nearest double bond, because that is a positive. Now this nearest double bond will that double bond one bond will go to the with electron, it will go to the that near that carbon and make double. Again from where this bond gone, there will be positive. Like that way complete positive will be whole benzene, all carbon, alternate carbon will get positive charge. Positive charge means rotation of positive charge at ortho position, ortho at first ortho, and then it will go to the after the ortho meta and then para. It will go like that. Okay. First positive charge is suppose ortho. Then now this positive charge will created alternate, means it will go to the next carbon, not just immediate next. After that, then that will be para position. Then ortho and para will be, you can say, positive. Then again it will continue. Then like that way positive charge will be complete in benzene ring. It will be just distributed everywhere. It will go. That's why it is stable. For a given alkyl, this I told about in case of benzylic halide. For a given alkyl group, the reactivity of the alkyl halide follows the same order in both the mechanisms. Okay, what is that? Now Ri, that is I am talking about in alkyl group, the reactivity of the alkyl halide Rx. X may be fluorine, bromine, chlorine, bromine, iodine. Then in case of Rx, follows the same order, means Ri will be faster than RBr, RBr is faster than RCl, RCl is faster than RF. I is big size, remember. Re is the faster than RBr. RBr is faster than RCl. And this will be, you can say, RCl is faster than RF. Okay. The mechanism I told the order that the order follows the same order in both the mechanism. Okay. Ri is the faster, faster, and this R I told you that is the faster than RBr, and RBr is faster than RCl, and RCl is faster than RF. Okay. Now I have discussed about this SN1 and SN2 mechanism. Now one problem I am telling you, that a problem may be asked in examination. What is the problem I am telling you? They have given question is that in the following pairs of halogen compounds, they have given two compounds is given, and in that you have to tell which would undergo SN2 reaction faster. SN2 reaction faster. Then SN2 means, now you are remembering SN2, second order reaction, means it will depend upon two concentration, correct? SN2, but one step. Now you answer question is that cyclo chain is there, CH2Cl is there. Okay, with the cyclohexane CH2Cl is there, and other is directly Cl is attached to the cyclohexane. One is cyclohexane, Cl is attached. Other with cyclohexane CH2Cl is attached. Then now you have to tell which would undergo SN2 faster. And now just now I have told you, just to think and then you answer. Now I am telling you that CH2Cl attached to the cyclohexane. It is primary halide. Because this carbon is attached to the carbon of benzene, this cyclohexane. Then it is a primary halide, and therefore undergoes SN2 reaction faster. Because it is attached to the primary. It is the primary halide. Why? Because this carbon is attached to the carbon of cyclohexane. Now another is that four carbon, after the fourth carbon I is attached. Okay, that after the fourth carbon I is attached, and other you have to consider that again same after four carbon Cl is attached. In one I is attached and a number of carbon is same, 4 in both cases, but in one I is attached and in second Cl is attached. Then now you tell me that is the SN2 reaction, which will be the faster. Then now I am telling you, as iodine is a better leaving group because of its large size, it will release at a faster rate in the presence of incoming nucleophile. This I am telling in case of SN2. In case of SN2. Okay. That's why this, when I is attached, that compound will be faster. Okay. As iodine is a better leaving group, because of its large size, it will be released at a faster rate in the presence of incoming nucleophile. Now, I am telling you next question. Actually, this type of question only is asked in any examination, particularly medical engineering. Only this type of question is asked. And listen carefully, and sometimes you have to explain, or you should know, because option will be option will be there for explanation. Option will be there with explanation, correct explanation you have to mark it. For that reasoning, you should understand this cause what I am telling you. Then now, what is the question I am telling you? First question is, the four isomeric bromobutane. Actually, here you have to predict the order of reactivity of the following compounds in SN1 and SN2 reaction. Okay. Now compounds, they have given compounds. Then you have to predict the order of reactivity. Predict the order of reactivity of the following compounds in SN1 and SN2 reaction. Then now here, first I am telling you the 4 isomeric bromobutanes. First question is that the 4 isomeric bromobutane is there. Means that 4 isomers of butane, bromide position will change. Correct? Bromine position will change in that isomer. Then now you think in this isomers, which isomer will be faster. Okay, after that I will tell second question. Okay, second question also I will read, after that I will tell answer. Second question is that this C6H5CH2Br, first compound, means with benzene CH2Br is attached, and other with benzene C6H5Br is attached. With benzene C6, with benzene I am telling you C6,5 means just like a CH2, in the place of CH2 one H is replaced by C6H5. That's why it becomes C6H5, and one bromide is there. First question I told you C6H5CH2Br. Only in that CH2 one H is replaced by benzene. That is the second. Then this is the second compound. Second compound of the second question I am telling you. Third is again now that in the place of C6H5 which was attached with CH2, now suppose CH3 is there. In the place of C6H5, now suppose CH3 is attached. For like a first question, CH2 was there. Then now in second question, benzene C6,5 attached in the place of one hydrogen. Now suppose in third question, in the place of C6H5, CH3 is attached. Means now it became with C6H5 CH3Br is attached. Third, and now fourth question is that now suppose in the first question CH2Br was there, it was attached. Then now both H is replaced by, one is replaced by CH3 and other is replaced by C6H5. Mean methyl and benzyl or phenyl you can tell. Methyl and phenyl. And bromine is already as it is. This is the second question. Then here also 1, 2, 3, 4 isomers are there. Okay, it is not 4 isomers. These are not isomers. Okay, here other question is the other compounds are there. Now come to the this thing first. First I told you, first question that you have to predict the order of reactivity of the following compounds in SN1 and SN2 reaction. Then now first question I am telling you 4 isomers, 4 isomeric bromobutanes. In that you have to discuss SN1 and SN2 reaction, which will be faster. Then now I am telling you direct answer I will tell you, and then I will give explanation. Then you know that one isomer will be, that bromine will be with last carbon. Suppose it is attached with last carbon. And second will be, now it will be in the last only. But now that one you can say methyl carbon number, this from the bromine side, if you will consider bromine as a first, then second carbon, third carbon, one methyl group is there. Correct? That is the second isomer. CH3 whole 2, CH2Br. Bromine will be that in both case and the end. Then now third I am telling you, then I will tell you explanation. Third isomer is CH3, CH2. Now bromine is at the second carbon. Bromine is at the second carbon. That is the third isomer. And fourth isomer is now that this 2CH3 carbon at carbon number 2 methyl group is attached. Means now it became propane. Total 4 was there. Then now at carbon number 2 methyl group is there. Then now total carbon 4 is there. Na? Then carbon number 2 methyl group is attached. Carbon number 2 methyl group is 3 methyl group is attached. Or you can understand like that, CH3 whole 3 CBr. CH3 whole 3 CBr is there. Means from that carbon only from which bromine is attached, 3 methyl group is attached. One up, other down. Then this will be a state like just like a propane, and one is methyl group attached. Means second carbon, with second carbon methyl group is attached. Then this I told you 4 isomers. Then now here just understand which reaction will be fastest and which will be slowest. Then now see that for SN1 I am telling you, SN1, this SN1, that bromine is at first carbon. Then now just to understand, of the 2 primary bromides, now consider primary bromides, which where directly bromine is attached and that carbon is attached with only one carbon. Then here are 2 primary. First and second, what I told, first is directly attached to the carbon. Then and that is attached with other carbon. Then continuous 4 carbons are there, but at the end only Br is there. Then this is the primary, and second primary is that when 2 CH3 is attached with second carbon. Then Br is attached with one carbon, that carbon is attached with another carbon. Then this is also primary. Then of the 2 primary bromides, the carbocation intermediate derived from CH3 whole 2 CH2 Br is more stable. Primary is more stable, than derived from CH3 CH2 Br because of greater electron donating inductive effect. If CH3 is more, then inductive effect will be more. Then now you can see that maximum methyl group is with the last isomer, what I told, 3. Correct? And least is with first. After that in second, 2 methyl group is there. And in third, bromine is attached with the second carbon. And last carbon, 3 methyl group is attached. Correct? Then this is tertiary, last is tertiary. And before the last, that is the secondary. And first 2 is primary. Then of the 2 primary halides, the carbocation intermediate derived from CH3 whole 2 CH2 Br is more stable than derived from CH3 CH2 Br because of greater electron donating inductive effect of CH3 whole 2 CH group. Therefore, CH3 whole 2 CH2 Br is more reactive than CH3 CH2 Br in SN1 reaction. CH3 CH2 Br CH3 is a secondary bromide, already I told you, and CH3 whole 3 CBr is a tertiary bromide. Hence the above order is followed in SN1. Means what is the actually final result I am telling you? CH3 CH2 Br, that is the less. In SN1 I am talking about. That is the less than CH3 whole 2 CH2 Br, and this is less than CH2 Br. CH3 is secondary is both primary is less than secondary and secondary is less than tertiary. That's enough. Now for the SN2, for this isomers, 4 isomers, now you consider for SN2. In case of SN2, what will happen? Reverse of this will happen. Reverse of this, both are reversed. Bulky group will create problem in SN2 reaction. It will be reversed. The reactivity in SN2 reactions follow the reverse order as the steric hindrance around the electrophilic carbon increases in that order. Very simple way SN1 and SN2. In SN2, no this alkyl group is required. No hindered group is required. Okay. Bulky group is not required in SN1. If it is there, then it will be less. Then how many are there? If it is more, then more less. Reaction will be further less. And reverse of this is in SN1. If more is there, if more bulky group is there, then it will can say reaction will be more fast because it will stabilize the carbocation. Now second question in that also SN1, SN2 you have to discuss, but it is related to benzylic chloride, bromide, benzylic halide you can tell. Then now here I am telling you that direct I am telling you, after that explanation I will give you. In case of SN1, now this cis benzene group we have to just to consider benzene group, and in that CH3, CH2 was there, na CH2 Br was there. Only that you are removing 1H, and in that place coming either CH3 or C6H5. Already I have discussed the question. Then now here you will find in SN1, that if in the place of 2 hydrogen, if 1 methyl and 1 phenyl group is coming, attaching with 2 hydrogen, correct? Then that will be faster. That will be faster. In SN1 I am talking about, will be faster, correct? Now 2 you can say bulky group is attached, 1 methyl and 1 phenyl. After that second will be, that is the 1H is there, 1 phenyl group is attached, means CH C6H5 Br is there. Only 1 hydrogen is attached with, 1 hydrogen is there, other hydrogen is replaced with phenyl group. Then CH C6H5 Br. And already benzene group in that CH C6H5 Br is attached. That is the second position. Third position is if with second hydrogen methyl group is exchanged. Methyl group, that is the third position. And fourth position is that is when neither both H is there, no H is exchanged, correct? This is the fourth position. Means first one is faster, when methyl and phenyl group is attached with CH2 Br was there, and that 2H is replaced, one by CH3, other by C6H5. That is the now fastest. After that second one, only phenyl group is there, H is there and phenyl group is there. The second position. Third position is methyl group is there, and fourth nothing is there, both only H2 is there, CH2 Br is there. This is the case of SN1. Now that in case of SN2, what will happen? Here now see that C6H5C, that is the what was the this same sequence is same. What I told in the case of SN1, now same sequence you understand, but it will be reverse case. It will be reverse. What was in SN1, what was in SN1, now it will be reverse of SN1 is SN2. Means now which was the fastest, that is the slowest. Means this what I discussed in the SN1, that you this greater than sign you can write that this greater sign only will change, that will come least, okay, that sign, arrow sign only will change. Less than means first is less than second one is less than third one is less than the second one, first one is less than second one is less than first one, correct? Third one is less than second one, and fourth one is less than third one. Reverse, complete reverse. Now again I am telling you, of the two secondary bromides, the carbocation intermediate obtains from C6H5CH C6H5Br is more stable than obtained from C6H5CHCH3 alkyl. There was phenyl, this is alkyl bromide, because it is stabilized by 2 phenyl group due to resonance. Okay, already I discussed. And therefore, the former bromide is more reactive than latter in SN1 reaction. A phenyl group is bulkier than a methyl group. Therefore, C6H5Br is less reactive than C6H5CH3, means alkyl bromide in SN2 reaction. Okay, this I have discussed, and now I am stopping only here. Next class I will discuss many important terms are there, and all important terms are important. So that is called a stereochemical aspect of nucleophilic substitution reactions. A stereochemical aspect. In that, what are the important terms will come? First term will be optical activity. Second term will come chirality. Third term will come retention. Fourth term will come inversion. And fifth term will come racemization. Then all these terms are important. Okay, and question is asked, which are optically active or not active, means dextrorotatory, laboratory, all things, means optical isomer I will discuss. Okay, optical activity, that is called in a one line sentence. Optical activity, chirality, retention, inversion, racemization, all things I will discuss in the next class. Thank you.